Hey there, Mart here. Okay, I set myself the challenge of trying to predict students' outcomes in their exams based on previous cohort data and their assessments. Can it be done? You can be the judge. I've got three tabs here on my sheet, and the first one is a complete version of what you're going to try to replicate. So you've got student data from previous cohort, and you can see I've created a couple of graphs to take a look at the equation that's showing the correlation and the relationship between the teacher predicted grade as an evaluation of numbers and their actual exam grade. So it's the previous students. And current students, we have the predicted grade and an evaluation of their different kind of metrics and assessments turn into a number. And then I've used the trend function here and the polynomial function with a linest function to give a polynomial prediction. And over here on the right, I've put the three sets of data together, the actual grade, trend, and the polygrade, and I've got a sort of visual representation of what that looks like as percentages for those students. So the actual grade that they went on to achieve, along with the predictions from the previous data to see how close they were. And it looks all right. So I'm going to move on to the predictor sheet, and this is where we want to get started then. So before you get working, you'll need to get your students. These students are made up. Their names are, but the data is actually real, because I wanted to see if using this technique would work and how as a prediction or starting point, a baseline. So teacher predicted grade for So was a B. Their actual exam grade was an A. If I translate those grades into numbers, you might use VLOOKUP to do that. Got 4 and a 5. So 4 for the B, 5 for the A. Let's turn those into the graph that we've on the other page so we can see the equation. So I'm going to highlight all of those. Insert chart. I'm going to stick with the scatter plot. But I want to add the trend line. So click Customize Series. Scroll down a bit. Use the trend line. I'm going to keep it as linear. Show R squared, and label change custom to use equation so we can see the equation of the line. And that was done. Just going to move that over, make it smaller. I'm not going to use the graph in any way to analyze the data, but I am interested in the equations. Now, to get the better fitting polynomial trend, I'm just going to click on the graph. I'm using a Mac here, so I'm going to Command Copy and Command Paste. It would be Control C, Control V if you're using a Windows machine, Microsoft machine. So I've gone into that one, me to copy. Let's double click, and I'm going to change the trend line from linear to polynomial. And I'm going to leave it on the second degree polynomial. Now, equation is turned on because I'm interested in the structure of this equation and the coefficients there. Okay, so with my current cohort, I want to compare or fit these grades that my students are getting from their teacher predicted grade compared to the predicted grade of the teacher for the previous cohort and what they went on to get. So let's do that. That works on the linear relationship. This graph, the first graph I've done, uses the trend function. So let's type equals trend. Fits points to a linear trend derived from least squares. So let's take a look at the help for that one. So trend, known data y versus known data x. So known data y first. known data y is what they got in their exam grade. So let's select all of that, comma, known data x, that was their teacher predicted grades, so it's that column. And then we're putting in the new data for x, which is the new cohorts, or current cohorts, teacher predicted grades. Close that. And there we go. All right. So now we want to work with the polynomial prediction, which is a little trickier. We need to use the linest function. I pronounce it linest. So up above here, I want to use that linest function. Best fit linear trend with least squares. So same idea. Data y, known data x, and we want to do a little bit of extra stuff to get the polynomial data right. So known data y, what the kids got in the previous cohort. Known data x, and this is where we now start going a little bit sideways from what the function, the help is telling us. So to the power of 1, 2, so the two polynomials, the second power, and close that function. And it's giving us hash value. An array could not be found. Now, for Google Sheets, we need to wrap this in the array formula function. And that gives us 3 pieces of data. So minus 0.35, 4.35, and minus 7.65. Now, the reason why I like to use the graphs, hang on, let me just freeze that. So I want to see, as part of the function, which of those coefficients represents which. So we've got 0.35x squared. So there's 0.35. And we've got the minus 7.65 is over here, not relating to the x value. So we know then from the graph that that is A, that's B, and that's C for the equation that uses equals ax to the power of 2 plus bx plus c. So there's that equation, and those are the values that we need. So let's plug those in then. Equals a times x squared, and that will be our teacher predicted value evaluation for Audrey here, squared, plus b times the evaluation. Let's wrap these in brackets, keep everything separate, plus c. Now I'm going to drag this down for my students, so I'm going to use absolute referencing and stop the function dragging itself down. And that gives a value of 5. Let's drag that one down. And now we've got those. Now to populate my graph here, it's a little bit of VLOOKUPing. So I've already got the students what they actually went on to get in their exam. So I want to see if my predictors are accurate. Now over here in my lookups sheet, I'm going to be taking a look for looking up these numbers and bringing back the grade letter. So equals VLOOKUP, and I'm looking up the trend prediction as a number. Go across to lookups, and I'm looking up all of those, and you'll notice I put those numbers out beyond what an A star actually evaluates, because sometimes the students do so well with their metrics used to predict the grades that their values go off the top of the range or below them. And I want column 2. Did not find value. That's because 4.9 isn't in that list. So we'll need to round the lookup. There we go. I'm going to drag that down, so I need that to stay where it is in the lookup array. So let's use the dollar signs. Drag you down. Okay. And let's do that again for the polygrade, but look up K4. All right. So now we've got all those grades built together and predicted and translated from numbers to letters. You can see the percentages are pulling through onto this graph. And the graph is showing us what that data looked like. So let's turn those off. So the actual exam grade looked like this for the subject. Not too many grades below C, D's, and F, below C. 30% B's, a lot of A's, 20% A star. So what did the trends look like? So there's the red line. So the predictor was a little bit short on A's, too many B's, but the A stars would look good. And then a similar trend for the polygrade, but it fitted better for the A's and the B's. I'd like to see this fit even better, and how we can do that is by using more metrics. So what assessments were used by the teachers that are useful and the most useful for predicting? So all I've done here is use one value for that. So a mock exam, for example. But what if we could add some extra? So I have quickly gone back and taken a look at other assessments and evaluated them together and summed their values for the previous cohort. And you can see now that the relationships of their evaluations versus their teacher evaluations versus their actual exam, the relationship has improved from around 0.6 to very close to 1. These are pretty good. I've taken this same metric, so the same assessments from the previous year and this year. I've taken the same assessments from the previous year and used those evaluations for the current year. And let's take a look at what has happened. The B's and A's have got considerably closer to what the students actually achieved. And indeed, let's take a look and compare these two. The blue line is the actual exam grade. Using trend alone, so a linear trend, it overpredicted A's, but got the A stars pretty close. In fact, they're exactly the same. Overpredicted the A's, underpredicted the B's, and the lower grades, it's maybe one student that's causing these 2.9%. Now let's take a look at the poly predictor. A stars, exactly the same. A's, short by a few percent. B's, exactly the same. A slight overprediction with the E's, but this is pretty accurate. I'm quite pleased about this. teachers can have a baseline on which to have discussions and add in extra metrics, use extra assessments to decide where students might go based on previous performances by other students. I don't believe in using data completely by itself, but certainly this is a starting point.